device that converts chemical energy to electrical energy. That is right. Please clap for him. So, an electrochemical cell is a device that converts chemical energy to electrical energy. Example of electrochemical cell. And what they do is that they convert the chemical energy to electrical energy. So electrical energy that produces is what is used to power your radio or your wall clock. Even your phone battery, the battery of your phone is an example of electrochemical cell. You know, when the battery is there, will the phone be powered? No. So it is a device that converts chemical energy to electrical energy. Now, B part. State the difference between an electrochemical cell. State three differences between electrochemical cell and electrolytic cell. Now, what are the differences now between electrochemical cell and electrolytic cell? Now, we have defined electrochemical cell. Then what is electrolytic cell? It is only when we know what electrolytic cell is that we can give the difference between the two. What is electrolytic cell?
It converts electric energy to chemical energy.
So that means the electrolytic cell is the inverse or the reverse of electrochemical cell. It is a device that converts electrical energy to chemical energy. You know, electrochemical cell converts chemical energy to electrical energy, but electrolytic cell converts electrical energy to chemical energy. And from the definition we have stated, we have given one difference. Usually when such is asked, you can write your answer on a tabular form. Now you have electrolytic cell, then we have electrochemical cell. We are given one difference. A device, you can see it converts electrical energy to chemical energy. Then this is, it converts chemical energy to electrical energy. When you give difference, your difference should correspond. A boy, a girl. Not that you say a boy, then he's dark. You know, you are talking of color, you are talking of sex. That does not correspond to difference. Now, that is one. Any other difference?
Electrolytic cell has only one half cell reaction, while electrochemical cell consists of two half cell reactions.
No, both has half cell. You have constitution half equation in electrolytic, so also we have in the electrochemical. Both has half cell equation. That is constitution half equation and reduction half. That's not the difference. Any other difference? Now let me make it simpler for you. If you have, let's say, this is a diagram that illustrates electrolytic cell. They can represent a typical diagram to represent electrolytic cell. So let us look at a typical example of electrochemical cell. You can see the structure: electrolytic cell, electrochemical. You can see the two as we have. This represents electrolytic structure. We have electrodes, then we have electrolytes here. We have electrodes, then we have electrolytes, then we have the salt bridge. From the diagram, you can see two main differences between the two. In an electrolytic cell, the electrodes are in two different containers in an electrochemical cell, whereas in an electrolytic cell, the electrode is one container. That is the difference. Both contain two electrodes, but in an electrolytic cell, the electrodes are into one container. That is one solution. Whereas electrodes in an electrochemical cell are into different electrolytes. Salt bridge. This is salt bridge. There is presence of salt bridge in an electrochemical cell. Do you have it here?
No, sir.
So you can give me that one. No salt bridge present. So it has, you can say, present of salt bridge. That's a good example. That is another difference. And in an electrolytic cell, anode is positive electrode, but in an electrochemical cell, anode is negative electrode. These are main differences between electrolytic cell and electrochemical cell. So, any question on that before?
How
Move on.
many
Yes?
different in electrochemical cells what are the signs?
No. What this one there is that whatever that is this chemical produce is an electrical energy, and what you know what is the rate is read by what the calorimeter. Instead of calorimeter, you can put a voltmeter here to show the amount of voltage that is produced. You can even put the voltage. Let's put a voltmeter here to determine the EMF that is. You know the EMF that is produced here will be the difference between the electrolyte, the electric potential of the right hand side and that of the left hand side. You know, in an electrochemical cell, they want to know the standard electric potential that is produced. That will be the difference between the electric potential of the right hand side minus the electric potential of the left hand side. But it can be cathode minus anode. Because you usually have your cathode at the right and the anode at the left. Is that okay? So let's move on to the when powders sink. When powders sink is added to a solution of copper 2 tetrahydrosulfate 6 in a beaker. Explain briefly what will be observed. When powder zinc is added to a solution of copper 2 tetrahydrolysis in a beaker. What will you observe when powder zinc is added to a solution of copper 2 tetrahydrolysis in a beaker? Anybody? Can anybody try the question? What you observe when the powder zinc is added to a solution of copper 2 tetrahydrolysis in a beaker? Yes? Formation of salt. You cannot see formation of salt. Now, one thing you don't realize is this. What is color of copper 2 tetrahydrolysis? It is what? Talk now. Blue. That is observable. You will see. By the time the copper displaces, that means the zinc displaces copper, what happens to the color of the copper? It disappears. To what? Colorless. And observable changes. You are the one that knows what the reason behind the reaction. But what you observe is that the solution will change from blue to colorless. And what happened? You know the copper, what is happening is that you are having zinc powder reacting with copper tetrahydrolysis aqueous. What happened is that copper will be displaced by zinc. Then it means you are going to have zinc tetrahydrolysis, which is now aqueous. They now have what? Copper standing alone. This is going to give you a brown deposit. That means you are going to observe two things. What and what? Solution changing from blue to colorless, and what? A brown deposit. Please learn how to answer questions. When people say what you observe, usually when reaction occurs, once you can observe that there might be change in the solution, color of the solution, there will be release of gas. In such case, you see effervescence occurs. They will tell us the color of the solution. Now let's move on to the next question. Now write an equation for the reaction. The equation is already written. We've written the equation for the reaction. Copper, zinc, CSO4, zinc sulfate, and copper. It is even the equation that will tell us what to be observed. Then the top part of that question now, state the type of reaction which took place. You mentioned that. What type of reaction is it? Displacement. And that was the question she asked. She answered. You know, there are two different things now. One question you have to, you added zinc powder into a solution of zinc copper 2 tetrahydrolysis in a beaker. What did you observe? The solution changing from blue to colorless and a brown deposit. Is that okay? Then what reaction occurs? There. It is displacement. The right reaction. We are getting the reaction. So we'll move on to the next question here. Name two gases which should be prepared in a fuel cupboard. Two gases that should be prepared in a fuel cupboard. What are the gases that can be prepared in a fuel cupboard? Gases prepared in a fuel. Can you give an example of the gases that can be prepared in a fuel cupboard? Yes? Anybody wants to try? Now, you have not heard of fuel cupboard before. A fuel cupboard is a device that is prepared prepared in the laboratory, especially where gases that are poisonous are prepared. I want to prepare a poisonous gas. Laboratory is a free environment. If the gas is produced, everybody around the laboratory will inhale it, and it is dangerous. A certain part of the laboratory will be prepared. The gas produced will go, instead of it releasing to the laboratory environment, it will release outside. It has exhaust outside the laboratory. Such cupboard is referred to as fume cupboard. That fume cupboard is a laboratory place where poisonous gases are produced or are prepared. Now, what are the common poisonous gases in the laboratory? Such gases should be prepared in fume cupboard. Example: carbon monoxide, chlorine, yes, H2S, hydrogen sulfide. Do you understand? So all these gases that are poisonous should be prepared in fume cupboard. Give 3 factors that favor cracking. 3 factors that favor cracking. What is cracking itself? Because the only way you know what cracking is that you can know the factors that can favor it. What is cracking? Let us know what cracking is. Then we can now discuss the factors that favor cracking. Yes?
Cracking is the breaking down of large hydrocarbon into
Cracking is the
breaking down
Yes.
of large hydrocarbon into
smaller hydrocarbon. That is right. So the breaking of large hydrocarbon into small hydrocarbon is referred to as cracking. Why do you carry out cracking in petroleum industry? Why do you carry out cracking? Why? What's the major importance of cracking?
avoid knocking on the head.
Yes.
You have made products.
There is major reason for carrying out cracking. Yes.
To increase the quality of petrol.
To increase
The quality of
no. To increase the quantity. If you want to increase the quality, you carry out reforming. There is difference between the two. Reforming is an isomerization process, making branches in a given hydrocarbon in a petrol is called reforming. You have hydrocarbon like that has, or you have a petrol that has long chain hydrocarbon. There's a carbon to carbon, carbon to carbon like this. 1, 2, 3, 4, 5, 6, 7, 8. By the time you reduce the branch, this one now, 1, 2, 3, 4, 5. As you are reducing the long chain to branch chain, you are carrying out reforming. And this is what we refer to as octane number. You want to know how quality the petrol is. You carry out reforming. The more the branches in the hydrocarbon, the better quality of hydrocarbon. But when you are breaking the hydrocarbon into smaller ones, the essence is that you want to increase the quantity. For example, diesel now. In diesel we have large hydrocarbon that you have in petrol. You can crack diesel to have petrol. Just like we have a liter of diesel, when it's cracked, you can have what? More than 1 liter of petrol. So cracking increases the quantity of petrol. Reforming improves quality of petrol. Now, that is not where we are going. The question says, what are the factors that will favor cracking? And I said there is no way to know the factors that favor cracking without knowing what cracking is. And that is what led us to cracking and reforming. has to give difference between cracking and reforming now. At least I've given 2 points. 2 points. What are the 2 points I give? What are the two difference between the cracking and reforming that I've mentioned? Yes?
Cracking is to increase the quantity of hydrocarbon.
Of petrol.
Why reforming is to increase the quality.
To improve the quality. That is what. What's the second one?
Cracking you want to bring down the raw material hydrocarbons to smaller extent. While reforming is the arrangement of raw material hydrocarbons to forms.
That is ISO. Please clap for it. Reforming is an isomerization process. In an isomer, what do you have? You are rearranging the carbon atom from long chain to what? To branch chain. And that's what happens in reforming. What are the factors that people cracking? Yes? Catalyst? Yes. Not just temperature. High temperature. The what? Or high pressure. The high must be there. Because if you have a low pressure or low temperature, the cracking will not be vapor. So high temperature, then we have high pressure, and the catalyst, they are the factors that favor cracking. Then we have give the reason why noble gases are chemically inert. Why are noble gases chemically inert? I'm also aware that why do they have stable? Because their outermost is completely filled. Because they have completely filled outermost shell. So they will not need electron from anybody. So they are referred to as a what are the properties of homologous series? Properties of homologous series? Yes. You born in here to produce CO2 and water, that is it. You complete born, yes. Successive member divided by CH2. I mean, we move from one member of that family to another. There will be difference of 1 carbon, 2 hydrogen atom. Yes? General method of their method is not general. They have similar. I've always told you that. The method of preparing one member will be similar, but not the same. Now, if you want to prepare methane, how do you prepare methane? Is the method you use to prepare methane the same way you prepare ethane? No, but it is similar. By heating soda lime with sodium ethanoate. If you want to prepare ethane, do we use sodium ethanoate again? No. What do we use? Sodium propanoate. Their preparation is the same. Similar, not the same. Do not write it that they have the same general method of preparation. The method of preparation is similar, but not the same. But they have general molecular formula. The molecular formula is general. And finally, we can say they have similar chemical reaction. Similar chemical reaction or similar chemical properties. Any question on that before we move on? Any question? Students? Okay. What is global warming? What is global warming? global warming? What is global warming? Anybody? The depletion of ozone layer is the global warming. It has to do with depletion of ozone layer. Yes. The increase in the temperature of atmosphere due to depletion of or due to presence of greenhouse gases or greenhouse effects. You know, when the ozone layer is depleted, what happens to them? There is going to be gradual increase in the temperature of the atmosphere. And what we call that? Global warming. So the increase in temperature of the atmosphere due to the trapping of heat, by greenhouse gases is called global warming. The increase in temperature of the atmosphere due to trapping of heat by greenhouse gases is referred to as global warming. State one cause of global warming. Yes, state one cause of global warming. Fluorocarbon. Yes, let's look at that. Fluorocarbon. The release of fluorocarbon can cause depletion of ozone layer, and when the ozone layer is depleted, there can be increase in the temperature. So, what other factor? What other factor that can cause global warming? Excess carbon dioxide also can cause depletion of ozone layer, and that will cause what? Increase in temperature of the atmosphere. Burning of fossil fuel can also cause global warming. So let's move on to the next question. This is our question number 2. All what we have discussed so far are question number 1. Question number 1. Question number 1 is for 25 marks. So that means if you have answered the question correctly, we have gotten 25 marks. That's again. So move on to question number 2. Define each of the following terms. Define each of the following terms. Roman figure 1, deliquescence. This is one of the questions or the topics that we did. Now, what is deliquescence? Deliquescence. I want someone to have Afiz. Can you tell us deliquescence is? It is the process whereby a substance on exposure to atmosphere absorbs moisture and turn to solution. The process whereby a substance absorbs moisture on exposure to atmosphere and turn to solution. That is what. Any question on that? There's no question on that. Efflorescence. Yes. Okay, let's have there at the front.
And then of process whereby salt releases part of its water crystallization to the atmosphere.
The process by which is salt, usually diluted salt, loses part or all its water of crystallization on exposure to atmosphere. It refers to as efflorescence. Now give one example of a substance that undergoes each of the processes above. What an example of the represent salt. You know, the question is on substance. It is not particular to a salt. I explained this one in detail when we discussed salt. The question is give one example of a substance. Is that okay? The example we want to give now could be a salt, it could be a base. But when it is mentioned, give example of salt. Is sodium hydroxide an example of a deliquescent salt? But it's an example of a deliquescent substance. Are we together? These are the technical things you have to look for when you are answering questions. But here it is mentioned substance. So example of deliquescent substances. Give example. I've just given one. Sodium hydroxide. Yes. Silica gel. Calcium hydroxide. Do you have calcium hydroxide here? No. Calcium oxide. Calcium chloride. Most chloride salts are deliquescent. Not all of them. Zinc chloride, calcium chloride, magnesium chloride, iron 3 chloride. They are all deliquescent. Now, example of fluorescent substance. Yes. CuSO4. CaSO4. You have the carbohydrate. It is Na2CO3 plus 10H2. You have calcium, the carbohydrate. Gypsum. Is it deliquescent? Now let us give common example. Washing soda, then copper tetraoxide pentahydrate. Is that okay? Na2CO3 dot 10H2O, then CuSO4 dot 5H2. Ionization energy. Ionization energy. What is meant by ionization energy? Victoria.
Ionization energy is the energy required to remove one electron from the atom or to remove one electron from an atom from this atom.
Right? Who can put it in a better place? Yes, let's have a great for it.
As the energy required to remove one electron from the atomic shell of a gaseous atom to form the gaseous liquid.
It is really when it is the energy required to remove one mole of electron from the atomic shell of an atom to form a gaseous ion. You know, when the electron is removed, the atom becomes what? Ion. When sodium atom is when electron is removed from the sodium atom, what you have is what? Sodium ion. That energy that is required to remove the electron is also as ionization energy. Is that thinking? The second ionization energy, write this one out. The second ionization energy value of sodium. The second ionization energy value of sodium. The second ionization energy value of sodium is greater than the first ionization energy. briefly give an explanation of this observation. I repeat the question. The second ionization energy value of sodium is greater than the first ionization energy. Briefly give an explanation of this observation. Here's it has been established that the value of second ionization energy for sodium is greater than that of first ionization energy. Does it briefly explain? You have not explained, you only confirm what the statement has said. What makes the second ionization value of sodium greater than that of the first? Yes?
This is because for the first ionization to occur, this energy is required because it is far apart from the nucleus of the atom. But for the second one, it is close a bit than the first one.
Exactly. Please clap for her. The second ionization energy value is greater than the first because the energy required to remove electron from the second shell, there is attraction between the nucleus and the shell. So it will require more energy for you to remove the electron than the first ionization energy. I want to take out the energy, the electron from the outermost shell. You know, that's the first ionization energy. The attraction between the electron here and the nucleus, the distance is far, so it requires less energy. But by the time you take this one away, this one is isolated. You want to remove the second electron. The position of this to this is closer. This electron here is attracted to this more. It requires what? More energy to remove it. The closer the nucleus to the electron, the greater the force of attraction. Is that not it? Then the more energy will be required to remove it. And that is why the second ionization is greater than the first ionization. Is that okay? Electron to remove the second electron here is more attracted to the nucleus. The proton dimension is in the nucleus. What do you have there? The proton, which is positively charged. Remember what we want to remove is negatively charged. So we move on to the next one here. State charge law. State charge law. I'm supposed to see many hands up. Is please, why are you rushing? Take your time and tell us. Yes, let us hear you again. Yes. At a constant pressure, the volume of a fixed mass of the gas is directly proportional to the absolute temperature. That's absolute is very important. We do not write temperature. You can see temperature in Kelvin. If the Kelvin temperature or absolute temperature is not there, it is 0. Next. Sketch a graph to illustrate Charles law. Can anybody do that for us? A sketch to illustrate Charles law. A sketch to illustrate Charles law. Yes? They have a sketch to illustrate Charles law. Yes. Please clap for her. Extended this your thing to this so that it will not be, you know where the value is. The -273. But it has to be a degree centigrade. The next question here. Now this is a calculation. A gas occupies 150 centimeter cube. A gas occupies 150 centimeter cube at 21 degrees centigrade. A gas occupies 150 centimeter cube at 21 degrees centigrade. What would be its volume? What would be its volume? If the temperature is raised to 45 degrees, what will be its volume? If the temperature is raised to 45 degrees and the pressure is kept constant, and the pressure is kept constant, and the pressure is kept constant. Quickly do it and let's see what you have. What's 62? What is B1? 150. And what's going to be our T1? 21 plus 273. You want to forget that the temperature there must be in Kelvin. Then we are looking for V2. Then what is T2? 45 plus 273. Then V2 equals to 150 times. What is 45 plus 273? 318 divided by, what is 21 plus 2? 294. Then V2 is equal to 162.2 centimeter. Please don't forget to put the unit. There is no units there. You are not going to be given mark for the evaluation. Chemical equations. Write chemical equations to illustrate what happens. Write chemical equations to illustrate what happens when each of the following oxides is dissolved in water. Write the chemical equations to illustrate illustrate what happens when each of the following oxides is dissolved in water. 1. Sodium oxide. Who will do that for us? When sodium oxide is dissolved in water, what? Come and write the equation that. Okay. Let's have the equation of what happens, or if you want to illustrate what happens when sodium oxide dissolves in water. Yes. You see, thank God I even asked you. If you write this thing for me in the exam, I will give you 0. Do you know why? Do you know why it's called 0? You don't know. You don't know, you know. Space. It's not a matter of space. Oxygen is represented by what? Carbon and carbon. Please go and learn how to write correct formula. You will give 0. What you have written here is H20, not H2O. Learn how to write formula correctly. If you mark, you do mark in reference to that. It ought to be Na2O plus H2O to give what? 2NaOH. Can you see my own? Learn how to write correct formula. Otherwise, you will 0. Number 2. That is the equation that occurs when sodium oxide dissolves in what it means sodium oxide dissolves in water to form sodium hydroxide. 2. Phosphorus 3 oxide. Phosphorus 3 oxide. Anybody? Is this the only one that can write the equation? Yes? Okay. Is it just want to try? Stand up now, guys. Nobody will kill you for me to draw that. Yeah? That's it. Okay, please. Let's go. Yeah, it's like he's in trouble. Do you have anybody that can help him out? He's already in trouble. You know why I said he's in trouble?
Yes.
You know the reason. Now tell us why he's in trouble. Let us hear you.
It's not fitting.
It's not putting say O3 is not what? Let us then. P25. I said phosphorus 3 oxide. I said what right reaction that occurs when phosphorus 3 oxide dissolves in water, not phosphorus 5. You know where I said is the problem is that when you write equation, there are two things involved: correct reactant and product. And when your reaction, if you have not written a correct reactant and product, it will be difficult for you to balance it. He has written wrong product. Automatically, it will be difficult for you to balance it. Are we together? That's what I said is the problem. Now, what you're supposed to write is H3PO3, not PO4. And I'm very sure if you are writing this one, we will have balanced it conveniently. So it is P2O3. You see now, you now have correct reactant and product. Then it will be easy for us now to balance. How do we balance? We can put 2 here. Is that not it? Then we can put 3 here. Is it not balanced? Is that okay? We should have written this at P4O6. This is 3 phosphorus 3 oxide. Then dissolve in water to give us what? H3PO3. Then what will be the balance of this one? It says H2O 4. Are we together? So let's move on to the next one. Number 3. Chlorine 7 oxide. Chlorine 7 oxide. Chlorine 7 oxide. Reaction that occurs when chlorine 7 oxide dissolves in water. Do you have anybody that can write the equation for us of reaction that occurs when chlorine 7 oxide dissolves in water? What do we do to balance the equation? If 2 is there, is the equation not balanced? The equation is balanced. What is the name of the product form? 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 Tetra isochloric 6. This is the product form. Is it not? What is the oxidation number of chlorine in this compound? What is the oxidation number of chlorine in compound 0? It is what? 0 plus 7. When you are asked to calculate oxidation number, if you don't put the charge there, it is 0. What? Plus 7. Then what will be the name? Hydrogen. And you are saying 6. So what you are telling me is that you use the 2 here. Why can't you multiply this one by 2? If you go by what you have here, everything will multiply by 2. And you are still going to get 7. Do you understand? So it will be 2 hydrogen, 2 chlorine, that will be 2s, and this is going to be what? 16. By the time you subtract 2 from 16, you have what? 14. Divide by 2, you still have what? 7. But the product is HClO4. The 2 was used to balance the equation. Yes. If you write this one for me, I will sample this place, I will sample this place, then 0. And you know the reason? That is what small letter N. It may be like a play. If you begin to, and when you write the equation correctly, it is 2 marks. If the equation is written correctly and balanced, 2 marks. You see, you have made 2 marks here now. And you have gone outside the gate to believe that at least those questions were so simple. Though the question was so simple, but you have committed what blunder when you are writing it. So when you want to write the question, take your time to write it. So that is that. So it also has been MgO plus H2O. I'm very sure you must have learned something today. So that when you write the question, you know you are supposed to observe that rule. We'll move on to the next question. Let's move on to question number 3. Question number 3. That is all what you have stated about there. Question number 2, which is for 25 marks. This is what you expect from chemistry. You know, one question you have different topics. It's only when you don't read at all that you will not be able to attempt questions from chemistry. One question you can have up to 5 topics, 5 different topics from one question. You know what you are doing at least. Chemistry is very simple to pass. Very, very simple to pass. That is if you obey the rules. God will help you. Write balanced chemical equations for the production of the 2 chloride by number 1. Direct combination of constituent elements. That means you want to form the 2 chloride. The 2 chloride can be formed in so many ways. How do we form it? By direct combination of the constituent elements. Who wants to try that? Yes? Come and write it. We want to prepare the 2 and the 2 chloride. The first method that we want to use is by direct combination of the constituent elements. How will you now write? Or how will you prepare that the 2 chloride from its constituent elements? Who will do that for us? So we are going to write the equations in order. Ojo. Yes. You are beginning to be conscious of what I want you to be conscious of. You know, N will not have a code. Please be conscious of all these things. There are some examiners that will overlook your lapses. There are some of us like this that will not even overlook at it. Once you have 0 like this, it will circle for you at 0. you meet such examiner, you have done the right thing. You need not to be afraid of anything. And that is what I'm trying to tell you. So now we have formed the two chloride by combination of the constituent elements, which are lead and chlorine. That is right. Now another way now. How do we form lead 2 chloride by double decomposition? Yes, that's it. Those of you are front end, you are not listening. What happens? Double decomposition. All this one I explained when we prepare salt. Method of preparing salt. Specifically, I told you the method of preparing soluble salt. Method of preparing insoluble salt. Insoluble salts are prepared by direct combination of constituent elements and by double decomposition. It means lead 2 chloride is an example of insoluble salt. Is it right? Is it right? Yes? David, you are saying something. Let us hear your voice. This has to do with your mind. Tell us what you feel about what he wrote. Is it right? Follow your mind. If it's not right, tell us what is wrong there. I've asked how to have not given you valid that maybe it's right or not. Yes? It's right. Why is it right? And I have to tell you that what is wrong. Scientifically. But a real concept of preparation of insoluble salt, it is wrong. You are supposed to use lead nitrate and a soluble salt, a soluble sodium or a soluble chloride salt, a silver chloride insoluble salt. No. What is wrong here is that you have used what? Insoluble chloride. You cannot use insoluble chloride to produce insoluble chloride. It has to be insoluble chloride. That means you can use either potassium chloride or sodium chloride. Do you get it? It looks as if you have prepared lead chloride here. But because of what you have used here, which is insoluble salt, it makes your reaction to be wrong. So what you are supposed to write is PPNO3 plus NaCl. Then this will now give us PPCl2 plus what? NaNO. This is now right. Please be watchful of all these small mistakes. The essence of using using the double decomposition is to produce insoluble salts. This method is specifically to produce insoluble salts. Though we have produced 2 salts, one soluble, one insoluble. But this method is specifically for preparing insoluble salt, which is what let's do. Then the next one, displacement reaction. Displacement reaction. Anybody? We want to prepare lead 2 chloride by Hafiz, yes, by displacement reaction. By displacement reaction. Is this reaction chemically possible? Is it? Because you see, when you write equation, you must be very careful of writing the equation. It looks like what you wrote is right, but it is wrong. Because silver chloride cannot dissociate in water, hence there is no way lead to displace silver. Though lead is more reactive than silver. But because it is not possible for this one to dissociate, because it's an insoluble salt, hence what is supposed to have used is lead reacting with dilute hydrochloric acid. Here now, lead can displace hydrogen. Then we have lead chloride, and there is what? Hydrogen gas. Is that okay? Okay. Yes, next question on that number. State one conditions that will increase the rate of reaction for each of the reactions stated above. State one condition that will increase the rate of reaction for each of the reactions stated in stated above. These are the reactions. These are the 3 reactions. 1, 2. What are the conditions that will increase the rate of production of lead 2? You know, once you are producing lead 2 chloride, what are the conditions that will increase the rate of production of lead 2 chloride here? What condition will increase the rate of production of lead 2 chloride here? And what condition will increase the rate of production of lead 2 chloride here? Now, let us hear it. Want to talk? Okay, David, let us hear your words. Your solution. So by increasing the concentration there, the rate of production of lead 2 chloride will also be increased. Then number 3. You know, temperature can also be used there. Increase temperature will affect everything here. You also increase temperature, the rate of production of lead 2 chloride will also be increased. Then number 3. Surface area of the because we are using solid lead. And also increase the concentration of HCl can also increase the rate of, because here this will be in solid, this will be what? Aqueous. Temperature. Increase temperature will increase production of lead 2 chloride. Using powder or increase surface area of lead will also increase the rate of production of lead 2 chloride. And by increasing the concentration of HCl, the production of lead 2 chloride will also be increased. Will pressure affect the rate of production of any of this? Will increase in pressure affect the rate of production of lead 2 chloride in any of the reactions? Why? Because none of them is in gaseous state. For pressure to affect the rate of production of a product, one of the reactants must be in gaseous state. And if you look at this reaction we have here, none of the reactant is in gaseous state. Is that okay? This is now an application question. Consider the reaction equation. Consider the reaction equation. That is the equation. State two conditions. State two conditions that would increase the yield of SO3. State two conditions that will increase the yield of SO3. Victoria. Increase in temperature, yes. Yield of the product. The question just say mention conditions that will increase the yield of SO3. So if there is increase in temperature, the position of fuel will move to the right. The more of SO3 will produce. So increase in temperature is right. What other factor? In pressure. Is that right? Increase. That's very important. If it is not, I like your style. If it is not increase, it's going to be decrease. How will a pressure affect the system at equilibrium? You must look at the total number of mole of gaseous reactant and product. All the reactant, the product, and gaseous state. Mole of SO2, 2 mole of SO2, 1 mole of oxygen. That is total of 3 moles. The mole there is what? 2 moles. Then, increase in pressure favors the side where there is decrease in the number of moles. Increase in pressure favors the side where there is decrease in the number of moles. Then decrease in pressure favors the side where there is increase in the number. Where do you want to move to? To the product. What do you have here? There is lesser number of moles here. Which side will favor this side? Increase in pressure. That's it. You understand? So, number 1, increase in temperature. Number 2, increase in